This is question 10. So this is one of the new topics on the A level. This is first principles, or differentiation from first principles. So you don't have to worry too much about actually remembering the formula, just know how to apply it. The formula is given in your formula book, so if you've got your formula book, check it out now if you can't remember it. So what we've got to show is that the derivative of x cubed is 3x squared. Now that's going to sound pretty clear, right? X cubed is 3x squared, but how do we prove it? Well, we can do it quite nicely with first principles. So, if I call it f prime of x, we can work this out. Now, this is the limit as h tends to 0 of x plus h, because we're looking where when we add a little bit to the x value, a little bit, and we carry on with the formula, what do we get? Now this is what would it be, this x cubed, right? So we're adding a little bit to the x. Minus the x cubed, f of x. That's my original function, f of x is x cubed. And this is all divided by h, the height, right? Now, so far we've got this. Where do we go from here? Well, what I'm going to do, just to make life a bit easier, I'm going to exclude the limit as h tends to 0 at each point. But remember, it needs to be there. I'll bring it back towards the end. So to make life easier, I'm just going to ignore it for now. What we've got up here is, three brackets, triple brackets, right? So we're going to need to expand that now. To expand that, expand your two first brackets and then expand one more. So what that is the same as is x plus h all squared, and then times it by x plus h again. So what you're going to get is x squared plus 2xh plus h squared, and then we're going to multiply that by x plus h. Minus my x cubed still. So if you're wondering what I've done here, I've expanded x plus h squared. So I've expanded it into two brackets like that, and it's still all over h. And my limit still goes here, so I'm just going to put dot dot for the limit here. Well, let's expand this again and work this out. So what this is going to be is going to be x cubed. So what I'm going to do is I'm going to write the simplified form. You'll get a few more terms, but if you simplify it correctly, this is what you should get. So you should get x cubed, and then you're going to get a plus 3x squared. Plus 3x squared. Sorry, that's a h after that as well. 3x squared h. You're going to get 3x h squared. Plus 3x h squared. We're going to have a h cubed plus h cubed. And then don't forget your minus x cubed at the end. Minus x cubed. And this again is still all over h. And I've still got the limit as h tends to 0, sorry. So I'm just going to keep putting the dot dots to represent that. I'll bring it back at the very end. Right. Well, hopefully it's clear to see that this x cubed here is going to cancel with this x cubed here, right? So what I'm going to get left with is the limit as h tends to 0 of 3x squared. 3x squared, that's an x. H plus 3x h squared. Plus h cubed. Alright, we're nearly there, guys. That's still all over h again. Right, we're nearly there. Now what we can do is we can actually cancel this h here, because it's just a denominator of h. We can actually cancel with the h's in the numerator. Well, h cancels there with that h. You're going to lose a h squared there with that h, and we're going to lose a h cubed. It's going to become h squared. So this is what I get left with now, right? I've now got the limit as h tends to 0 of 3x squared. 3x squared plus 3xh plus h squared. Now what I'm actually going to do is I'm going to rub this out just a sec, just because I want to write the limit actually in here. So it's hopefully nice to see what's going on. So this becomes now the limit where's my pen gone? There we go. So the limit as h tends to 0. This is what we're actually taking the limit of now. Of this full expression here. Kind of cut it a little bit with the brackets, but we're taking the full limit here, where x tends to 0. Well, if x tends to 0, this term is going to disappear, and this term is also going to disappear. And if you see, this is what we were looking for. We wanted 3x squared, and that's what we needed at the end. So, I'd write something like this. As h tends to 0, h tends to 0, f prime of x is equal to 3x squared. And there you go, guys. That's just what you need to prove at the end of the very last line of your working. So all you do, get your formula going, put your x plus h all cubed minus the x cubed, because this is your f of x. Keep going with the formula, make sure you're expanding correctly. Be very careful when you're expanding. Divide through by the h, and then take the limit at the very last step here. So make sure you write the limit in at each step. So this, where I've put a dot, 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 this is just the limit as h tends to 0.